All right, well, first off, thank you everybody for showing up this morning. I know mornings can be very difficult at Infocom to show up sometimes, but today we're going to be discussing 1 gig versus 10 gig, different applications, different expectations. I apologize for my voice. You can only imagine. Been doing a lot of talking at this event, so it's still hanging in there. So you constantly hear 1 gig versus 10 gig. There's certain manufacturers out there making the claims that 1 gig is about as good as 10 gig. The debate's over. All this nonsense. So this is kind of what we're going over with, is really where certain things start and where they end. It's not really so much about what is better than what. It's really what's meant for what application and what you're trying to do and what expectations you're trying to get out of it. So what's all the hype that we're talking about here? So the first thing is image quality. Okay? So right off the bat, you're talking a 20-to-1 compression when you're doing 1 gig, when you're dealing with 4K 60, 444. That's a lot of compression. Now, I know there's tricks you can do to make it look better, which is why we call it visually lossless. You're trying to trick the human eye. And it's not to say that they're not doing a good job at it. Actually, for 1 gig, it looks very good. But the problem is, let's look at the applications for it. When you do medical, can't have much latency there when you're doing OR rooms. When you're doing virtual reality, milliseconds make the difference. When you're dealing with gaming, same thing, makes all the difference. Broadcasting makes all the difference. These are important things when you're doing these. And right now, the 1 gig does have latency. And that brings us up to the second part, which is 1 to 2 frames of latency. That's not acceptable in those applications. You can claim it's as good, but it's not. Latency is latency. You can't do cute marketing to say no additional latency or it's as good as what our prior product was. If your prior product did 1 to 2 frames of latency, which it did, that's not acceptable. Right now, the fact is you either have it or you don't. And right now, the latencies are fluctuating between 1 to 2 frames, and we've even seen sometimes more. But now a secondary problem happened. You could play tricks with it. Now static images look better. Good for them. They did a great job on it. However, what happens once you apply motion into that? Well, it's got to fight. You can't just build everything up and pretend like it's okay. So as soon as you put a little bit of motion, everything starts to reveal itself again. And now what you start to see is breakdown of the image, because now that compression engine has to start working again. You can't just buffer up and build things up. And what happens is you're going to see color changes, and you're going to see things altering itself, and you're going to see motion artifacts, which we actually have demonstrated, and we videotaped this to see. But usually I tell people, try it for yourself. Even out here, don't believe all the hype. Manufacturers come here, we're all guilty of it. You want to put on your best show. But the best way to do it, and especially with SDVoE technology, is to just try it. Put the test patterns in, put them side by side, see what happens in the case studies. Don't turn on all those little tricks to try to make it look better. So you'll see those tricks played where, look, the timing's the same. Yeah, if you put seamless switching on, it's the same. Because what does seamless switching do? You have to use a frame or two. But when you turn seamless switching off, amazingly enough, you're not going to see the time frames the same. You're going to see one with about almost 2 frames of latency. So what happened? So it's great that they could pick certain modes to make them look better, but the reality of it is that's not a true test. That's just working around the system to make themselves look better. And who does it really hurt when you really think about it? You're going to go in with a false expectation when you go into the actual application. Now you get into power consumption. I know it sounds strange and I'll explain it, but when you're looking at SDVoE products, the typical power consumption is under 18 watts, okay? And sometimes less based on what design it is and whose product it is. They're doing almost 35 watts, and even their newer versions of products that are out there, they're still using PoE Plus, which is closer to over 20 to 25 watts to make the thing work. When you do compression, it takes a lot of resource inside those processes to deal with those algorithms that have to move the information and encrypt it and decrypt it, okay? That's why their power is so much, and they're never going to have an ASIC of it because they make too small of a quantity. While they may brag about some of the installs they did, in the scheme of things, it's minute. You don't go making regular chips when you're doing that small of a quantity. So one of the things that SDVoE is doing is they're coming out with ASICs. And that means power consumption. And I know it's not everybody who knows what an ASIC is, but the ASIC is when you actually have a processor that is a dedicated function and that's all it does in life. Most everybody right now are using these programmable processors, which consume a lot of power, and they're not burned in as a specific technology. They're molded into whatever you try to make it, and those technologies use a lot of power. That's why you don't see wall plates in there. That's why you don't see other derivatives, and you won't see any of those. That's why you see all these workarounds for these problems. SDVoE, probably by I'd say by Q1 of next year, they'd have to answer this more than I can, but you're looking at products that are going to potentially run on standard PoE. Forget about even PoE++ or PoE+. We're talking standard PoE. We're going to have products that are going to actually be able to live inside projectors or displays or media players, products that have no fans, no heat sinks, because it's running cool enough to just work as its own. And the price points are also going to drop simply because the technology is now burned into an ASIC from a semiconductor company. So as some of you are aware, SDVoE is not just an organization, it's also the support for the company that makes the semiconductors, which is Semtech. So this isn't just about a chip that's out there. This is about an actual predetermined chip that's going to carry a very specific function that is going to deliver an interoperability across the industry. So it's a very important delineation as we move forward with SDVoE to understand that this is more than just saying, oh, we got a better image, oh, we got this. This is about interoperability between many manufacturers, kind of in the way that HD-based T has been known in the industry for, except now we're doing it on a wider platform, on a nearly unlimited expandability of matrixing. So you get into other claims that are out there. You'll see, oh, it doesn't work on regular CAT cable, 5E or 6. Okay, well, once again, not true. Look at the standard specification for 10 gig. 5E will go 40 meters, CAT 6 will go 55 meters, and CAT 6A will go 100 meters. So where the claims come up that it only works on CAT 6A or 7 is a bunch of nonsense. You just got to go on the internet, because everything on the internet's 100% true. So, and you'll see there, it's a standard spec, and it's nothing different, nothing unique to SDVoE, because they're following networking standards, and that's what you see. And then you get into the cost perspectives. You'll see a lot of nonsense about, oh my God, 10 gig is so expensive. Well, just keep in mind, 100T was the server class decades ago, and it was expensive as anything. 1 gig eventually became the server class. 100T was cheap as anything. Now 1 gig, you go into the store, you buy a switch for barely 20 bucks now. 10 gig, yes, when it started out, server class, but now you got 40 gig, you got 100 gig, right? So look at how the costs have dropped down. I've seen switches on the market, 16 port, 10 gig switches for as low as 500 and change on the market. So when you see these things that they throw up there, oh, it's $30,000 for it. I don't know where they're buying their stuff from, but if someone's paying for it, please buy the switch from me for $30,000, because it's not out there unless you're going looking for the most obnoxious price. The reality of it is companies like Netgear, which is an SDVoE partner, and they got their frame over here, has made a commitment to making out-of-the-box working switches, which isn't just for SDVoE, it's a standard network switch, but it just happens to come pre-configured to make it easy for the installation, so it comes at more like that matrix experience where you have to know less about the matrix, or the IP I mean, and treat it more like a matrix from that out-of-the-box experience. So it helps out a lot, and their 96-port switch also does PoE, which also helps with the implementation. So if you think about the irony of it, you got these 1 gig products that have to run PoE Plus and PoE Plus, which not many switches that do PoE Plus out there, as you're very well aware. And yet here we are with 10 gig and we're doing regular PoE. Kind of ironic how that actually works in this particular case. So the cost is not nearly where it is, and even in Aurora's case, we have products that are less than some of these, what they call premium 1 gigs. So what is the reality of the 10 gig? So when we're looking at the image quality, remember I said it was 20 to 1. Well, we're looking at 1.3 to 1 compression. So anything under 3 to 1 is a lossless compression. So these are terms that you see mixed up very heavily. There's a difference between a lossless compression and a visually lossless compression. Visually lossless is something that tries to fool the human eye into thinking it's okay, just like the MP3. And people say, that's not real audio. Kind of the same thing there. Okay? Anything over 3 to 1 starts to fall into that gray area of visually lossless. And yeah, unfortunately, there's no real standard for how to determine what is acceptable and visually lossless. There's different techniques, different ways of doing it. And once again, based on application. So the other thing too with 10 gig is because of the bandwidth and the fact that we're not compressing it heavily, only 0.1 milliseconds. and that's with the lightweight compression. And actually, there is only, I believe it's 22 microseconds when you're doing the HDMI 1.4 modes and below. That is a true zero frame latency. You're talking 100 microseconds compared to 16.6 milliseconds of a full frame. Now, as you could tell, that's true zero frame, not what we used to have, and it's comparable. Very big difference. So the other thing too is, and I already kind of went over this, was it was price was compared to it. So the other thing too that people don't think about, that they're not pointing out because not to their advantage, but when you're doing a 10 gig drop, it's not just about the video, it's about everything else that goes along with it. So one of those things is you have 1 gig Ethernet. So every time you make a drop point, it's like adding a free 1 gig Ethernet port. So if you have a 96 port, let's say, implementation of 10 gig, you just gave yourself a 96 port 1 gig switch simultaneously at every single drop point. That doesn't happen in the 1 gig world. You got to run a second cable. Now let's take into the fact that USB 2.0, it's a term that's very loosely used. Yeah, anybody can claim 2.0, but are you going to get the full bandwidth to deliver the cameras or the other high bandwidth requirements? If you're eating up over 900 megabits per second on the USB, on the 1 gig LAN, how are you going to do 480 megabits per second of USB? It doesn't exist. You don't have the bandwidth to do it. That means you'd have to drop the bandwidth down, which guess what that means? More compression. 20 to 1 is going to go out the window, and now your image quality is going to go down to fit the bandwidth. So what happens? They barely do 50 megabits per second. Technically, it's still USB 2.0 because you're doing higher bandwidths than the 1.1, but the reality of it is it's not the full bandwidth, and it will not deliver the expectation for it. So that's a very important thing that's never brought up, is the convenience of what happens when you do one single wire drop and what it's going to give you for that value versus having to do 3 wire drops of a 1 gig implementation when you're doing it. So other thing too is when you have that much bandwidth, you get to do something else that's really good. Windowing. 10 gig allows you to actually manipulate the image ahead of time, send it over, and then create windowing out of it. 1 gig, it's a lot harder to do because you have to pre-construct it and then resend it back into the system, which is actually more expensive to do. So one of the things that you don't hear about is to do windowing on a 1 gig, you actually have to add in additional equipment in order to pull it off. Because to even do 4 windows, they now need an engine that has to be able to decompress or encode 4 images at the same time and put them back together. Well, if they're doing 35 watts only trying to deal with 1, could you picture how much it's going to heat your house if you have to try to do 4 of those at the same time in order to put them back together again? It's not going to be pretty. So that's some of the realities of 10 gig. Now, applications for the 10 gig. Right off the bat, if you're doing 4K 60 444, it's 10 gig at that point. You're dealing with a bandwidth that's going to add in a lot of artifacts if you try to compress too much for the certain applications. It sounds good, but the reality of it is, at that point, you're just into the 10 gig realm. Corporate who requires high image and wants the bandwidth for 2.0, whether it's for KVM, distributing the content, so on. Medical. I know some companies, they loosely turn around, oh, it's okay to look good. Yeah, maybe for observation decks, but when you're in the OR room, and if anybody's ever talked to doctors, the color of the red, the gray scales, all that matters. And that's really the difference between a right diagnosis and a wrong diagnosis. 10 gig, because it's a lossless compression, delivers exactly what you see. So what you see is what you get. Not playing games, not waiting for things to actually happen. Gaming. So if anybody's done gaming or esports, timing is everything. These are guys who look for monitors that have like 3 milliseconds, and if it can be even faster, they will, because their reaction times are amazing. You add in 16.6 or 32 milliseconds to their gaming system, that's the difference between them making a big mistake and losing that tournament and succeeding and having a good day at it. So gaming, very important right there when you're dealing with guys who have very amazing reflexes. Broadcast, same thing. You're trying to deal with, you're performing live. We all know what happens. You get 32 milliseconds. We're doing a John Lennon recorded in the bathroom. So for anybody who knows how he recorded some of his stuff. But anyway, that's what happens. You're going to get that beginnings of the delays that you're going to have to compensate for. So for live events, not really a good thing to be having that latency in there. Prosumer, once again, they want to do HDR. They want the best. They're doing the home theaters. They don't want any type of artifacting. That's where, once again, 10 gig comes in. Virtual reality, trying to trick the human mind. You cannot be altering the image, changing the colors, having artifacts. Once you do that, you are not getting the realism of what you're trying to achieve with virtual reality. So from virtual reality standpoint, once again, perfect for 10 gig. 1 gig falls short on that stuff. So let's go over the reality of 1 gig. So when you're doing the lower bandwidths, typically the image quality is visually lossless and 8:1. We do make 1 gig, so I'm not saying that you can't use 1 gig, but once again, price points, applications, backbones, different things that you're up against. So in this case, you're talking an 8:1 versus a 20:1 on the 4K 60. Your typical latency you're going to see out there is a 1 to 2 frames, and sometimes even higher based on what they're doing in their processes. It is cost effective, there's no doubt about it, because for now, 1 gig network switches are still a lower cost, but the gap is slowly narrowing to it. The USB is limited to the bandwidth that's available, as we already discussed. There is no 1 gig Ethernet. Typically, maybe a 10-100 connection that you can possibly pull off with it. And as I pointed out earlier, it's really hard to do windowing on a 1 gig without adding in additional equipment that it has to feed in and back out through, which adds additional expense to it. So applications for it, which are totally acceptable and great for 1 gig, low cost distribution, restaurants, casinos, malls. For today's price points, and this is where unfortunately you lose the premium 1 gig, like, yeah, I'll pick on them, restaurants, you're going to lose that premium point, because most of them do not want to spend that much, and if you're spending that much, you might as well just get a 10 gig at that point. But they want very dirt cheap, and the 1 gig, there are 1 gig products, yep, we happen to make it, where they're lower cost, they can deliver good quality, and they're used in the restaurants, casinos, and malls. Education, K through 12, they don't have much budgets. Once again, the low cost implementations of the 1 gig products. Corporate, low cost conference rooms, house of worship, those type of things. Now when I say the low cost 1 gigs, there are ASIC implementations of the 1 gig products, and those are where we put them into the lower cost. Do they have the same quality as 10 gig? No. Do they look pretty good for the expectation of the application and deliver a very good quality image? Yes, they do, and they're perfectly acceptable. Eventually, 10 gig will replace the 1 gig. It's inevitable. Technology has shown. As I said, 100T replaced 10T. 1 gig replaced 100T. 10 gig is going to replace 1 gig. 40 gig, it's going to keep going. This is the evolution, and history has proven itself for that. So the bottom line. So this is where I could just talk anything I want to. Yeah, this is a bunch of nonsense on the screen. I put this on purpose. So this is where I could just ramble. So anyway, the reality of things here is everybody's going to have their take here inside the industry. They're going to show you their best game. What I really encourage everybody to do is take the test patterns that are available, try it out for yourself, see it, compare it, and make your own determination as to what truly is better. Do a little bit of the research yourself, because as I said, everybody's going to tell you what you want to hear. Even SDVoE might be doing that. Sorry, SDVoE. But one thing I'm comfortable about working with SDVoE for all these years is, and I've been able to comfortably do it in my booth, is I could time and time again prove that what you see is what you truly get, which is what's great about the technology. And as I stated, for these applications where that level of quality, that level of performance is expected, there really is no other choice than going with a 10 gig. And that's pretty much what this presentation really outlines more than anything. So any questions from anybody? Quiet crowd. Did I actually answer everything that well? I can't imagine I did. I'll settle for that one then. Well, thank you everybody for coming this morning. I know you all have a lot to do, and that's it for my presentation. Have a good day.